In this video, I'm going to go step by step with everything. These are the steps involved. Um, Gathering all the data, we have a lot of it, but we need to add the links above. Um, we need to find the water data set, which I can find pretty easily. But along the way, this is very important. We're going to be creating a web map. I've created web maps before. I'll give you a link in the job post. So create a project file and add data. This is already done. We have to have a 3857 projection, and anywhere along the way, we have to first reproject the data before we do anything. And so I have a cutout of Missouri. This is the cutout I created. There's two cutouts. One is the actual border of the state. Oopsies. Um, and one is, so you can see here, okay, I don't know what's going on here. One is the border of the state and one is outside the extent. It's actually better we should do it outside the extent of the state because there's kind of overlapping data here, and in the end we're going to have to kind of cut it, slice it out. Um, So the basic process after that, after you cut out the Missouri sections for each data set, you would reclassify the vectors, resample them. You would create a 90-meter resolution raster. Pretty low res, but high enough that you kind of can create a general habitat suitability model. Um, and I'll give an overview of that in a second. This is where I am right now with things. I'll just go through this. There's version one, and I showed you this version earlier. Um, and this has some things that are kind of correct, some things that are not. It wasn't done right, the vector rasterization and resampling. So we're doing it all over again from scratch. Um, so let's see here. We have in this file, and these are the files you'll see in your sample. Are these? You would see population density. I'll just show this. This is the population density. This is the land cover raster. This is the slope data, and these are the roads. And so there are several kind of individual issues with these, but and it explains that below. But um, um, I'll explain the general process using one or two layers. So, okay, we'll take version two, and why don't I take population density? And this is the original vector data. What I'll do is I'll zoom in. I'll just zoom in like right there. And as you can see, these are kind of the 90 millim. I believe that this is the 90-meter resolution data. So there are these squares, 90-meter squares that make up everything. Like you'll see this square, this is 90 millimeters. I'm sorry, 90 meters by 90 meters wide. And this is the original, sorry about that. This is the original vector data. So you can see this is what it did. It converted it to from a raster, sorry, a vector into a raster. Um, I have to switch back and forth. I'm sorry to pause and play the video. So that's an example where I went from a vector to a raster, but here's a land cover raster. Um, this is up close with it, so this is what it looks like far away. Don't know what happened there. Um, Give me a second. This is the land cover raster, and it was already a raster before, but let's see here. I'll explain this. Why don't I just zoom in here, zoom in, and we can see it up close. That's that 8-bit thing. So basically, okay, this is, you'll see that this is higher resolution. This was at 30 meters. And this has 18 different, I believe 18, yeah, 18 different land cover types. Um, and what we did, according to the paper, is bring it down into 8, reclassified them into 8 types. So, there were, for example, several different uh, barren types. There was barren land, and there was developed land, and there was water, and so on. I need to change one thing there. I just noticed. But so what you do is in that case, what I did, I'll just scroll down real quick. I used ChatGPT to just create a nice little script that just reclassified it into these 8 categories here. There were 19 classes that were reclassified. So after that, then um, so that's the reclassified sample, and then um, after that was all done, then it was turned into a 90-meter resolution file. And I will show kind of some issues that I'm facing right now. This is what we need to do kind of right now is, let me perhaps zoom into this area here. Let me just zoom in there. There are issues like these are not aligning. These squares are off. Hopefully I can find a quick example here. Okay, that's not a great example. Okay, still not finding the best example, but this is population density up super, super close. And this is the land cover raster very close as well. And if I were to flip back and forth, like look at this corner here or these lines, you'll see that they do not align. This right here, this is the corner up here. You might want to put your finger there. What I'll do is I'll go in this corner like this, and you'll see that you see this corner right here. right there. You see that corner? Um, if I were to unselect, you'll see this is the corner up here. So these are not aligned. And I believe that we can kind of get away with it, but I don't think it would be best if we could get all the squares here to align with each other. So that's kind of the situation I'm at now. That's kind of the next step. So if you can basically take this, we started with this land cover raster. You might have to redo that and then redo the population density raster, do one or the other, and in the process, make sure that it all aligns. I have no idea how to do that. That's why I'm hiring you. So we go through each of these factors here. Land cover, this is that script I mentioned, and this is the resampling script. It turns um, raster, any given raster, into a 90-meter wide raster. Um, and population density, it explains that this is the one for population. Oh, well, I yeah, it's the same script involved. Distance from paved roads. We haven't done this yet. We have an existing roads map, but there's an issue with it, and that is that if you get super close to it, okay, population density, I'll just minimize that. Minimize. Used for, okay. This is the roads used at the moment. These are paved roads. However, I don't think that these are all the paved roads, and so we need to find this data set again and redo it. So, we might want to get paved roads within cities as well. I think that that would be a good idea. Now, one issue that I don't really know how to deal with is that, like, highways are often wider than 90 meters, or either that, or, you know, so if you look at the factors, it has the distance to paved roads. Uh, on the road itself, it's 0. It actually makes that distinction. And this zero point 0.3 kilometers thing, you know, if you resampled it, it might be a little bit off, and I think that might be cause an issue. I'm not sure. And these are just center lines; they're not like right of ways. It would be nice if there was like a if we used right of ways. But again, this is like maybe 90 meters wide, and if the square was cut off here versus here, that could make an issue. I'm really not sure. So that's roads, slopes, distance from water. Yeah, we're going to have to find this again and download it again. I have it, so we can just use what I have, but I would like to download it and use it again, just so that we have the original data and we're connected to it. Um, and the hydrography data set, we need to download that, and generate the buffers and resample it. Um, okay, so in the end, all of those 5 factors would be combined into one weighted layer, and I do not understand what that means. I could use ChatGPT at some point to give me a step by step, but we have to create each of those. They have to be aligned 90-meter rasters, and then they would be combined into one that will give the habitat suitability rating, which would be 0 to 100. And then what you do is you combine those areas into you take out the ones that are 75% suitability, and then you combine them into 2,500 kilometer square areas, which is like 50 by 50 kilometers. That's the minimum size for a breeding population. And this actually varies, like the opinion on it. So they actually created four models using these. And we should do that too, because the variation, even though these seem like small variations, the results are really, really different for them. So if we were to look at this, you know, okay, let's go down, 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 down. The difference between these is really big. So this is one model, and this is another one. You'll see a lot more habitat and a lot more lines between them. So we're wanting to create something with like all four of these models. Um, and then you create the LCP, which involves the least cost path, which involves the least cost path analysis, and you would get to that. But this is a part that I do not understand. You would apply a 1 kilometer buffer because it would be best if it had that much room to move through a cougar. Um, so I don't know how they would apply a least cost path with a buffer when a least cost path is just a single line. But yes, land value mapping. This is a very interesting one. We have a data set for land value, and it's at a pretty high resolution, and we actually do need to resample it. It's I believe it's at 30-meter resolution, which is I'm not sure about that. So then when we do that, we're going to combine land value and habitat suitability and create our own ranking for it, and then animate it as well, like create a new map that shows. um, so for example, if land value were $100 and the H habitat suitability was 100%, like it was a perfect habitat, then it would be value would be 1. But if it was the worst habitat, then the valuable value would be 100. And if it were kind of okay but really not suitable, 50% suitable, then it would be 2. Um, so obviously you'd want something pretty close to 1 in that case. But the higher the suitability or the higher the land value, obviously these numbers would increase, and we would have a surface raster in the end that we use for a cost path. And I'm not going to show this in the video. Well, okay, I should show this. This is what we're actually going to create in the end, so I really should show it. Um, you open up this. I have this sample here of this animation. So if you were to click play, basically, okay, it's a 3-second video. Um, what you'll see when I click play is the land that is the highest suitability and lowest cost. It starts off from there, and if you were to buy all that land, what is the best land to buy, basically? So, it starts off like this. This is the area that's the best, and in here, there's the value of the land. So you would spend, let's say, $4 million buying that much land. These numbers are probably wrong. They could be way, way off, but this is just the concept, so don't worry about it. And then you increase it, and as you can see, it becomes squares, like larger squares. But well, this is from the previous one, so basically, I'll just play this over and over, and you'll get the idea. we're going to create an animation for the whole state of Missouri. Um, let's go back down. So once we're done with this, we're going to create the animation, and then we're going to use soil maps to create a rewilding map. So for example, um, this is not good, a good data set, but I should show it to you. Um, what I'll do actually is I'll just show a map online. Um, okay, this looks like a pretty good one here. This is Missouri soils. Hopefully I can just open this. So it's very low resolution, but basically, this is what the land kind of looked like before. Um, Large scale settlement, very uh, large scale agriculture and cities and so on. The green areas, I'm assuming, so there are all these different soil types. Like this red here is kind of very heavily forested, maybe mountainous. The yellow here perhaps is more grasslands. This area, no idea. And these areas are probably more like marshy wetlands. And these are the areas that would be best for cougars, but these areas would also work, especially along these river areas, I'm assuming. So basically, we would take this and create a map of what the land looked like. I'm just taking the leap that a soil map resembles what the natural landscape without humans. If humans were to disappear, this is what the land would look like again. So um, I'll just give another example. Like this is another example of a map. So this is another example. It looks pretty different from the other one, but soil classifications get really deep. Um, Mississippi alluvium, Ozarks, etc. This is the Ozarks area. And each of these have different land covers. So, yes, like this is where St. Louis is, and this was wooded slopes. So, yes, all these soil maps look very different. So, it's all very confusing to me. I'm going to probably have to talk to a mapping expert, sorry, a soils expert to understand them, but we'll get there eventually. And when we're done with that, then we're going to resample it at 90 meters and combine it with the land value and suitability map. And then we're going to create the final map, which is a land value rewilding habitat suitability map. And basically, it's going to be an animation of, like I showed you before, if you were to purchase land at the lowest cost, highest suitability rating, and highest rewilding potential, how much would the land expand given society's budget? Let's say we were to want to spend $100 million over several years expanding habitat. Where would it be best to spend that money? That is the ultimate question. Where is it best to rewild land? So, in the end, that's everything. You're going to have to go through all this, and I'm sorry this video is probably extremely long. But yeah, that's an overview.